So then we'll also go over to how to access the Emerging Threats Open Rule Set, which is free. You can use that in your environments today and take advantage of the rule sets that we publish. So like I mentioned, there is if you have Discord, you can join that chat group. If you have any questions, concerns, complaints, hopefully not many complaints, but if something's broken, you need help with your VM, whatever, just drop it in there, or just raise your hand, flag me down, and we'll take care of it. There are no stupid questions. Other people might have the same thing that you're concerned about. Maybe I'm glossing over something. So really feel free to ask away. Oh, and I should mention that if you follow Emerging Threats on Twitter or our discourse, there is kind of a recurring theme of the Garfield cartoon, and so you might see that spread throughout the slide deck today. So what is an IPS or an IDS? Stands for an intrusion, protection, or detection system, and the naming really depends on how you have this sensor deployed. So protection system is going to be if you're blocking traffic. If you just want to get the alert, send it to your SOC, your SIM, whatever, it's going to be called a detection system. Signatures are an example of static detection. So dynamic analysis, that's when you're executing something in a VM, interacting with it. Signatures are considered static. They're used to detect anomalous traffic. You can use them to detect like policy violations, so like gaming in your environment, or APT-related traffic. Traditionally, these sensors sit at a network perimeter, but nowadays with more of a focus on lateral spread, you'll see people deploying sensors internally to monitor east-west traffic. A lot of vendors use open source engines, which is pretty cool. The vendors get kind of a head start on their products and take advantage of this open source code, which they can modify, and then kind of in return these detection engines get more widespread and just more awareness. So here are a few of the engines that I'm going to mention. Probably the main one that people know is Snort, which is a network-based IDS. It's created by SourceFire, which is now was purchased by Cisco. They have a community edition of Signature, so just free for the public, and then also a subscriber edition, which is more for enterprises or if you want to pay for kind of premium content. Suricata, which is this logo over here in the top right, is another network-based IDS. It's created by the Open Information Security Foundation. And you'll see as we go over the signatures today, there are a lot of similarities with Snort. Yara is, I think, has one of the best acronyms. It's yet another ridiculous acronym, but it's a static detection tool for mostly files, but some vendors will use it to detect email content or other text files. But what was that? Memory analysis. Thanks for adding that. That's developed by VirusTotal, and in VirusTotal, if you kind of have a premium edition, or I don't know if they give it just to vendors, but you can actually do Yara hunting in VirusTotal, which is pretty powerful.
They have what's called retro hunt. You can get a virus tool where you can test URLs
Yeah, so that's a good point. VS has retro hunt, which you can, if you find like a new sample and you want to see if it's existed before in the wild, you drop your YAR rule in. VS will let you run that across like all the samples that have previously been uploaded. There's also an option you can just drop your YAR rule in, and then it will alert on new files as they're uploaded. We've got ClamAV, which is maintained by Cisco. It's another static detection tool for files. It can be used on all operating systems and run as like a standard AV. You'll see that a lot on Linux, sometimes on Mac. One of the cool things about ClamAV is it can inspect into archives. So for like Word documents, like docx format is just an archive, and if you run strings on that, you're most likely not going to find like all of the content in the macros that you want to sig on. And ClamAV can essentially like open that archive in real time, look for those strings, and then detect on that. So emerging threats, just had to throw this in. We're not an IDS engine, but we create Suricata signatures for the community. We have an open subscription, which is free for everyone, and then also Pro, which is the paid tier. So today we're going to focus on the newer versions of Suricata, starting with version 5 and beyond. It has some differences that have made rule writing a lot easier, but the syntax is basically the same so far from Suricata 5 and above, and I think we're on 7 right now. So what does the signature look like? This is an example of one of the open signatures we have. Looks kind of confusing if you haven't seen this before, but I'm going to go ahead and break it down line by line. So on the first line here, you can see alert, HTTP, some variables, home net and external net. We're going to dive into this, like each component, a little bit deeper. But alert is the action, HTTP is the protocol. Suricata has a ton of different protocols that it supports, and you can write rules just on like TCP or UDP, but there are some really powerful features that you can use if you're trying to detect one of these specific protocols. Today we're just going to be focusing on HTTP. Message, this is just the human readable name. Good for your SOC, whatever, just makes it easy to identify. The flow, you can detect on the where the initial like communication started, as well as the flow type. So if you want to detect on like an established or like a non-established flow, then you have that option. These next two lines, you can see it starts with http.uri, and then also on the next line, http.useragent. These are called sticky buffers, which allow you to look for just specific parts of the PCAP for your content matches. So it's just a little bit more efficient than like if you did, you didn't use a buffer, it's going to look for through the entire packet for, you know, the URI baby.php or that user agent string. The next line, we've got class type. Here at Emerging Threats, we have a set of class types that we use to define like just generic like Trojan activity, command and control. But really, if you're writing your own signatures and deploying them in your environment, you can use custom class types, and whatever makes sense for you guys, then you can use that. But what you want to do is really make sure that you're being consistent with your class types, because it will just make the alerts more valuable and useful for your SOC or whoever's reviewing these. SID, this is the unique identifier for the signature. And then rev, this is revision. So basically for change control, whatever, every time you make a change to a signature, you're going to want to increase the revision, because then you can reference back to maybe like there was a false negative on revision 1 or a false positive was fixed, in revision 2. As you're improving and tweaking the signatures, it's good to know if, what these change or what revision of this rule you're on. And so I don't know if there are any questions so far. I'm just going to check the chat here and hopefully not. There we go. Switch my screen up. Okay. So looks like there's nothing in Discord.
I haven't been able to get the Discord link to work.
Okay, sorry about that.
You said it to expire?
I made it like a few days ago, so it probably expired. Okay, and also I meant to upload a PDF version of these slides to that Google link. I'll do that right now too. Copy link.
What would be the biggest difference between Snort 5 and Snort 3 and Suricata 5?
Yeah, so Snort 3 uses sticky buffers just like Suricata. So, they have, very similar, overlapping functionality right now. Right now we release Snort 2.9 rules, so I've mostly worked with that. So I've dabbled in Snort 3. Some of the major differences that I've seen are how Snort does thresholding to limit alerts to, if you're doing a DDoS rule or something like that. Snort 3 actually has removed the threshold keyword in rules, and you have to manage that in a separate file. Okay, sorry, I'm getting the Discord link here. And sorry about that. Thanks for letting me know. Okay, copy this. Okay, so there's the Discord link. Okay, sorry about that. Presenter view is PowerPoint is not my strong suit. Okay, were you able to get that to work? Oh, it'll probably make sense if I delete that first line. Oh, I guess the Discord lets you
I don't think it's working.
do a shortened link.
It's just blank. Okay.
You have to resort to real life chat.
Right, yeah, we're just gonna have to talk.
Well, he's mainly to get around the stuff. File transfer.
Hey, nice. Cool. Then what I'm gonna do, let's leave that up just for another sec, and then I'll upload the slides to this same Google Drive link. I meant to do that before we started today, and last night I was like still tweaking my slides and then just spaced it, so. Cool, looks like we've got more people joining. But yeah, that's what I'm talking about. That was a good complaint. Okay. File, export. PDF. Okay, I'll get those uploaded. Okay, so that's going. Cool. So the rule format, just a little bit more in depth. The action tells the IPS how to process the traffic. So there are different options: alert, drop, reject. Basically for today, we're going to be using alert, which most IPSs will also use that option to block the traffic. But like maybe if there is, you want to like block IP or ICMP at your IPS instead of like anywhere else, you could drop it just to simulate like that ICMP is down and not serve a response back to the requester. The header defines the protocol, the IP addresses, ports, and direction of the rule. So TCP in this case is the protocol. HomeNet, this is basically a network variable that I talk about a little bit more on the next slide. So you've got HomeNet and then any after that. I guess, as you can see there, that's the port specification. And then you've got an arrow to determine the network of traffic. To external net, that is just another variable that's set in your config, and then also any port. Then the rule options are everything else in the rule, the message, your content matches, references, and whatever else you want in there. So HomeNet and external net. Your HomeNet should be everything you're trying to protect. And kind of the rule of thumb is if you don't know what's supposed to be in your HomeNet, you shouldn't be deploying the IPS because there's a high probability that you're going to cause some damage to your environment. External net should be traffic outside of the network you're protecting. And Suricata, and then newer version like Snort 3 and above support protocols. And so what this means is Suricata is going to recognize HTTP traffic over non-standard ports, which is really powerful because in older versions of Snort and Suricata, you'd have to specify, hey, this is going to HTTP ports, which is normally like port 80. You might include like 443 in there if you're doing like SSL intercept. 8080 if you have a proxy, whatever. But like in the case of this PCAP, you can see the destination port is like 14,651, which unless you have that in your variable, your rule's gonna FN. So flow, this can determine, like I mentioned, if you want to alert on some additional context. So for example, like established, you probably want to use that if you really want to know that your client has made a request and connected with the C2 server. Up here at the top, you can see to client, to server, and then from client and from server. And so these kind of overlap, like to client and from server, that's the same direction. In emerging threats rules, we use to client or to server. And if you're gonna write your own signatures, it's best to just pick two and stick to that, because if you're reading your signatures, you really just want to be able to identify like where this traffic is going, like what is this rule looking at, and so being consistent in these flow settings is going to help you out in the long run. So the determination for established depends on the protocol. For TCP, this is going to be after a three-way handshake occurs. The signatures we're going to be using today, we're looking at HTTP traffic, and we'll be using established flows in our SIGs. So you've heard me mention buffers. What is a buffer? In Suricata versions 5 and above, like we were talking about, Snort 3 and above, there are sticky buffers, which means basically you specify the buffer and everything that comes after it is part of that buffer. So in this example, you can see the buffer HTTP response line and then the content 403 forbidden. So the reason why this buffer is important is because maybe your traffic sees a web page come that just says 403 forbidden in any part of it. That's going to be a false positive. If you use this response line buffer, you're only going to see the alert if the actual server response is a 403. And kind of the way I like to visualize it in my mind, maybe this is confusing, but think of it as a bucket that basically contains everything after it until the next sticky buffer occurs. So any of the content matches, and you can have multiple that follow your sticky buffer, are part of that. And we're going to be using a few today, so hopefully it makes a little bit more sense as we progress through our signatures. Here are a few examples of HTTP sticky buffers that this is just from the Suricata documentation, but you can see there are lots of parts of like a HTTP request that you might want to alert on. So like the URI, probably one of the most important ones. The method, headers, and as you write signatures, you'll get more familiar as you want to get your rules more and more specific. And kind of like I said before, Suricata has buffers for many protocols, and so it's if you're writing something or a rule for like SMB, SMTP, you can go in and check out the buffers for that and just make sure your signature is like as precise as possible. So I don't know if there are any questions. I'll go ahead and check the Discord.
So a buffer is pretty much just like a content match, but just on that specific part of the packet.
Yep, yeah, it just limits the your content match to a specific part of the packet. And that way too, it really can make your signatures perform a lot better, because if the Suricata engine only has to look at like one specific part of the HTTP request, it doesn't have to evaluate the rest of the packet.
Does that improve performance then as well?
Mm-hmm.
How it processes everything?
Yeah, for sure. Especially if you have, like, let's say a response coming from like a C2 server that has like some encoded payload. Suricata is gonna, if you don't specify a buffer, it's gonna look through that entire like payload response for as much as it supports. For like really large payloads, you kind of have to be creative, but so it'll improve performance. Oh, and yeah, for one example, I guess like an easy one I'll mention is the like HTTP host buffer, which is just right here. An example of that, like the content match would just be google.com.
So for the buffer, can you specify multiple buffers in a single rule, or are you kind of limited?
Yep, definitely. And so as we're going through the lab today, we'll build our rules out, adding more and more buffers and increasing the revisions. But that's a good question. Yeah, using multiple buffers in a rule, it just helps you get more and more precise. As you want your signature to be like a scalpel instead of a hatchet. So. Okay. So sticky buffers, continuing what we're talking about, if you're using, or if you've seen like older snort rules, you have to specify, like for HTTP URI, you'd have to use that multiple times in each rule, and it just makes your signature longer, harder to read. But sticky buffers were introduced in Snort 3, kind of in Suricata 4, but everything moved to a sticky buffer in Suricata 5. So consider this URL. We've got malware.biz/stealer, and then maybe some indicators that's like it's exfiltrating a number of passwords, number of credit cards. So if you want to use multiple parts of this URL in your signature, all you have to do is specify HTTP URI and then just add the parts that you want. So you see I've got the HTTP URI buffer here, stealer, passwords, and cards. These are the 4 buffers we're going to be using in our signatures today. Looking at the HTTP method, the URI, the user agent, and then the request body. So looking back at, this was the original signature we mentioned. I don't know if anyone wants to like identify one of the buffers and then the content in that buffer. I'll just check the Discord, but that's fine if. So yeah, in the HTTP URI buffer, it's just baby.php. The user agent buffer, you've got this Mozilla line, and then those are the 2 buffers that are being used.
So is that an and or is that or?
It's an and. So you can do negations in signatures too. So if you don't want to match on like specific user agents or something, but everything in the rule is going to be an and, unless you do negations, or you can do like these rules support PCRE, where you can do ORs, and then also basically just whatever you do with PCRE, anchor it, capture groups. So that's where it gets really fun, is if you have like a really long pattern in a URL or something, you can get creative with PCRE, which, yeah. And the thing to know with PCRE is it's going to really impact the performance of your rule. If it's like just something, a really loose PCRE, or like looking at a long string, that's going to decrease performance on this rule, increase the load on your sensor, and then if you have a bunch of rules like that, you'll probably notice you'll start having some issues with your sensor.
So fast pattern means that it's a regex? Or?
Yeah, so I didn't include these in the training, but fast pattern specifies what the sensor should look for first. So Suricata will add its own fast pattern by default. It will just like has like a formula that it will go through, but basically what the fast pattern is doing here is it ensures that this rule, Suricata is going to check the user agent first. And if that user agent doesn't match, then it's just going to move on to the next rule, or pass the packet on, whatever. So fast pattern is definitely something you want to use as you create like more and more complicated rules. And I can actually add that in today if we want. And another thing you'll notice in this rule is there's starts with, which, on the other hand, you have ends with. We're not going to use these today, but it just tells Suricata in this case, hey, in the HTTP URI, look for baby.php only if it's at the very beginning of that URL. So it helps you be more precise, and you might not want to alert on any URL that has baby.php in it. So that helps you just get your signature more and more precise. Okay, so now we're going to get to the fun part. And we'll see if there we go. PowerPoint transitions were working. So this is our file that we're going to look at first. You find it on a Windows 7 box on your network. You forgot to upgrade it. Whoops. So search for the hash in VirusTotal. There's a large number of hits from various vendors. The file name is stealer.exe, so that seems pretty suspicious and looks like something we're going to want to look into further. So we're going to see if the file lives up to its name. Going back to sandboxes, they're great for quick analysis. We're going to be using triage if you haven't used that before, and I was just going to ask everyone to set up an account for that. Because we'll be submitting files to generate PCAPs from there. And pretty much anywhere you're submitting files, you should know that you're going to lose control of where that goes. So anything uploaded to VirusTotal, Triage, AnyRun, whatever, it can usually be downloaded by either just like any user, or like a paid tier can usually go in and download those files. And kind of one of the fun things that I've seen people do is they'll create like a YAR rule and drop it in VirusTotal, looking for strings like top secret or classified, whatever, and then you'll find that someone in a government agency uploaded a file there and just like, didn't really realize that now that's out of their control. Oh yeah.
In terms of sandboxes, like how safe is it to use the Windows sandbox? Like say you didn't want to upload it up into the cloud, do you just use a Windows sandbox to
Yeah. So
analysis?
what was that?
Oh, could you use the Windows sandbox to perform analysis?
Oh yeah. So you can just set up like your own like dynamic analysis environment wherever you want. What you really want to do is make sure you know like, hey, like I disconnected this VM from my work network or something, so it's truly like sandboxed, because you don't want to be detonating malware on like your computer and it does like, it escapes it, like infects your computer, does like some lateral spread to like another box in your network. So definitely like doing your own local dynamic analysis has value, especially because you get to like maintain control of your files.
But
And
you
then
probably don't want to do it off your own workstation, is what you're saying.
yeah, having like a dedicated box and like a dedicated network are really preferable, which is not always like feasible, especially depending on like your network environment, whatever, your lab that you set up. But yeah, so these are just a few that are popular. AnyRun, Joe Sandbox, Hybrid Analysis, these are all great. There's Cuckoo, which is open source, and it's really cool and really powerful. You can set up like multiple operating systems, different agents. You can set up like multiple Windows versions with different Office versions on it, and it will create, it'll capture the traffic from that analysis, give you like a report of all the changes that occurred. And so it's definitely a time-consuming project, but it can be worthwhile, especially if your company doesn't have like a budget for like a FireEye, like Sandbox or whatever else. And the reason why I chose Triage today was, one is the free tier of it offers SSL intercept. So basically it's going to man in the middle all traffic going through it. So if malware samples are using HTTPS, you can still see that in your PCAP, write a signature on it, and then assuming your company uses SSL intercept, you'll be able to block that traffic. Okay, so we're talking about this VM. The VM is just a modified version of Remnux, which was created by Lenny Zeltser. He's the dude who is in charge of the GRAM or like 4610 certification from SANS. And it actually has like its own update tool in it where it will pull in like the fresh versions of like Didier Stevens tools, Yara, whatever else. But it's just got like a ton of malware analysis tools on it, so it's worth checking out its capabilities. The password is malware, and that's the same for Remnux. Notable files here are in the home directory, Dalton, start Dalton. This is going to start the Dalton engine that we're going to be using to test our signatures on. And as I was playing with this VM, if you restore to like the most recent snapshot, it has Dalton already running. And I found that running the startdalton.sh does a lot of like updating to the Docker that it runs in. So if you want to restore to the snapshot, it has that all running, but you can manually start it, and it I found out it takes like a couple minutes. So but then on the desktop there's bsides.rules, which is the signatures that everyone's going to be creating. I'm working from there. Solutions.rules, this is just rules that I came up with if you want to check your answers. PCAPs. These are generated just from triage that I ran earlier and downloaded in case like anything weird happens with our triage submissions. So like if for whatever reason something changed, at least we know that these PCAPs are correct. One thing to note in here is there's a phishing PCAP, which doesn't have a sample associated. And then malware samples, we've got the binaries we're going to upload to triage. So I don't know if there are any questions. Let's check the Discord. Okay, so understanding the triage submissions, I'll go ahead and run through this in the VM, but some of the options that I like to use are just if you select automatic for like Windows binaries and Word docs, it's going to spin up a Windows 7 and a Windows 10 VM. So usually automatic is fine unless you really want to test it against like a specific OS version. The languages option is really cool because if you suspect that like a binary has language evasion, so I've seen it like recently, there will be like a Russian sample targeting Ukraine. It will check if the system language is Ukraine, which it unfortunately isn't an option on here yet, I don't think, but there's something cool with like a current event. The internet access feature is really cool. What we're going to be using today is the 200. So if the C2 server is down and like let's say a sample needs to like before it really detonates completely, it might do like a check to the CNC server and say, hey, is my server up? And then if it does that check and maybe the sample is older, it might not like finish executing. So this will simulate a 200 response just at the client, and then hopefully that will keep the sample detonating. And the reason why you might want to do that even if the C2 server is down, for example, is this case where we found a binary on our Windows 7 box. Who knows, like when this infection could have happened when the C2 server was live, and then maybe we get some IOCs we can go look for in our SIM or a firewall, whatever. You can change the timeout. On the samples today, you can leave it like 1 or 2 minutes is fine. Okay, so this is just a overview of the summary, and I'll go ahead and submit this into VM, but I just figured I'd show this first. You can see in the top right, there is a separate analysis for both like Windows 10 and Windows 7 boxes, and where you really want to check, you want to look through both reports because a sample might detonate better on like Windows 7 versus Windows 10. Which I've seen is still the case. And when you're downloading a sample, download the PCAP NG, which is going to include the man-in-the-middle traffic. Resubmissions, this is previous submissions from like, maybe like someone submitted it 3 days ago and it has a higher score. Maybe the C2 server was still up or it was able to download a payload. So, okay, so I'll go ahead and let's go to our VM here. Cool. So in your VM, if you open up the web browser, I've added some tools here. Dalton, this is what we're going to be using. This is what it should look like. We've got CyberChef, Triage, just some emerging threats links, and then I included a link to Remnux, which is this VM, and the Suricata documentation, which is a great reference. So let's log in here. And these samples have the password infected, which might be obvious based on the naming schema. But by default, Triage is going to try that password, so you don't need to do anything there. Automatic, I'll just leave it, set it to 1 minute. 200. And the kind of a cool thing to mention with Triage is, you can move the mouse and interact with it. Maybe a useful tip is if you open just a folder and go to temp, this is where it launches all the samples from. So if you need to go in and execute the binary again or reopen the Word doc, if it auto closes, then this is where it's going to be. Okay, so Windows 7 completed before Windows 10 did. So looking at the results from this, it's identified it as Eternity Stealer spyware. I'll go ahead and just download this PCAP. So if you scroll down, it's got some cool stuff you can look at, but I'll minimize signatures. You can see all the commands that it ran, and minimize that. Then this is what we're looking for, is the network requests. You see a post, couple IP API, maybe it checks its IP address, so here's our post, Stealer, and it looks familiar to what we've already seen in the training. Passwords, cards, wallets, files. So this is definitely exfiltrating something. We've got that PCAP downloaded, and we'll just open that. And we'll see if I was testing this last night and was getting some slightly different results. Okay. So I'm going to go back to our slide deck real quick. Okay. So we've detonated the sample, got our PCAP. We looked at the network requests, and we'll go through the Wireshark basics here that we're going to need for writing our signatures. This isn't a Wireshark course, but this is just going to be some really basic things to get some content matches for our rules. One of I found the most useful features for if you pulled up a PCAP, you've never seen it before, open up statistics, conversations, and what you can look for is, hey, are there any ports that might be suspicious. So you can see port A on this is like in the port range that hosts can use dynamically. And then port B is 14,651. And looking through an entire PCAP, you might not have noticed that, or this at least draws your eye immediately to the this IP address. And basically, we saw that port. This immediately drew us to an HTTP request on that destination port. The next thing is following HTTP streams. You're just going to right-click on the packet, go to follow HTTP stream, and that's going to show us the client and server responses. This is just an example of that. And then the details window. This is important for Suricata and snort rules because we were talking about sticky buffers, and you can see here it breaks it down by the method, URI, request version, host, user agent, and you can basically just right-click, copy these values, and drop it into your rule, and then you know exactly what is in the PCAP. Whereas like maybe highlighting it, copying it, or just looking at like the follow streams, it might not be exact, but you can just copy and paste it from here. And one thing to note on this is you can see the host has the port specified after it. The HTTP host buffered it doesn't include those ports. So it would just be the 103 IP address. Okay, then the other thing we're going to use in this class is exporting HTTP objects. Just file, export objects, and then HTTP. You can filter by HTTP request, and then also, if you want to get more specific, limit it to like a get or post from the method, and then TCP destin source port is going to let you filter that traffic down by port. Okay, so we're starting our signature now. We're going to start with the template. What you got to be careful for with templates is copy pasta. There's like a lot of times I'll start with a signature that already exists, and I might like forget to change the flow or like the home net, external net variable location. So if you don't get it correct, then your signature is not going to work as expected. So are there any questions before we start writing the signatures? I'll check Discord. Okay, VM download very slow on this internet. I have USBs that have just the VMs on it. If you trust me, I've got the VMs on there, or you can wait for the VM download. But if anyone wants these, I can pass these around, and I promise I haven't done anything to them. But right, I know, yeah, exactly. I took off my hacker badge, so.
Are the images signed? Do you have like the file?
Oh yeah, I should have hashed it.
It's like 75% done.
Okay.
I don't know if it'd be faster USB or.
It probably is, but do you want me to walk this over? Anyone else? Okay.
I gotta put it in my transfers. I don't think I have.
Oh, USB-C.
I have a
Wait,
bunch of
I got a dongle.
Okay.
Mine's ancient.
No, you can still use that. I got it down.
Oh, you do?
Oh.
Okay. Even
Here you go.
better.
Okay, sorry.
Oh.
It's the smallest flash drive, sorry. Cool. One thing I was just going to mention is in our VM we're using Sublime Text, and one of my coworkers made a Suricata syntax theme for Sublime Text, which is helpful for using buffers. There's also, if you prefer VS Code, Stamus Networks has syntax for that, but today we're just going to be using Sublime. Cool. You can throw it at me if you want. Okay. So, like I said, create an account to triage. Go ahead and submit the sample, download the PCAP NG, which the traffic is just HTTP. It's not SSL intercepted, so it doesn't really matter for today. Open up Bsides rules. Open up Dalton in the browser. Once again, you can use start Dalton if that needs to run, or if that's not running, I guess. So just highlighting a few things before I start, move over to the VM. But if you open Dalton in your web browser, the flow here is going to be click new, Suricata test, and Dalton is actually really cool. It just runs in a Docker container. You can test snort rules, Suricata rules, and then also Zeek, which I haven't played around much. I think that's a newer feature. But one of the other more powerful things that's built into Dalton is FlowSynth, which you can play around with, but it allows you to craft your own PCAPs. So if you just have like the plain text of PCAP, or like even better, someone sends a screenshot of a PCAP, which is my favorite, or a screenshot of like a SHA-256. I'm just like, you can type that into, or OCR that, drop it into FlowSynth, and it'll craft your PCAP for you. So upload your PCAP with this browse button. Uncheck use defined rule set by default. Dalton actually downloads the emerging threats open rule set. So if you don't uncheck that, you're going to get a bunch of alerts that aren't your signature. Check use custom rules, and then for this first submission, we don't need it, but going forward, check the dump buffers. Okay, and this is just what the results page looks like that we'll go over once I run this in my VM. Okay, so this is what so I'm going to go over to the VM real quick. Moving displays around. So this is one thing weird I found out last night was this is the PCAP I just downloaded from my triage submission. You can see I did the filter HTTP request, and it's only showing this get JSON, even though in the triage web interface, you can see that there was the post request. So my original PCAP has the correct request. I'm not really sure why that's not showing up with this filter. You can still use this PCAP and it will work, but I'm going to bounce over to my PCAP I already have generated just to kind of show you that the traffic is still in here. I'll just do this. So I just did TCP contains stealer because we know that exists in the URL. Follow TCP stream, and so this is the post, but so yeah, like I mentioned, I'm just gonna go to the pcaps folder and open up sample one. Okay. So this is our right-click, follow HTTP stream. I'm just going to minimize this stuff, kind of clean up my desktop here. Open up bsides.rules. And so we're working on sample one. This is the first revision of our signature. To start, we're just going to copy and paste this in Dalton. Go to Suricata, choose your PCAP. Like I said, it'll still work on your downloaded PCAP, but I'm just using sample1.pcap. Use custom rules, dump buffers, and I don't know if you can see it or if you open your rules file, but this rule doesn't have any buffers. It literally just says alert HTTP and then established flows to server. So this is not going to be a good rule, but let's just try it out. And there are 51 alerts, and there's only one URI in there that we cared about. So we are going to want to fix up this rule. And the first step that we're going to use is implementing the HTTP method. So I'm going to flip open the slides just to show the syntax you want to use. But kind of the idea that I had here is as we're going through in each revision of the signature, you would try your copy pasta error, get your copy pasta error, dump it into, I'll expand this, maybe. Dump it into Rev2, update your revision. So I'll go back now, slides. Oh yeah, thanks. Okay.
More romantic.
Okay, so revision 2, basically the usage is take that rule that we just had and implement HTTP method with the content match here. So literally it will just be the one content match and then add this buffer. And one thing I highlighted is the method is a post, and this is the view from the details window. So if everyone wants to try and do that and implement this sticky buffer, then we'll just give it a minute and make sure that everyone kind of has this down before we move on to building our signature further. So if there are any questions, let me know. I'll keep the Discord open and I can walk around if you need any help. And a key thing here as you're implementing these sticky buffers and content matches is notice that after each item, it ends with a semicolon. So you have HTTP method and semicolon space and then the content match. So content quotes with what you're going to put in there and then semicolon after that. Oh, yep, and that is the right Dalton. Yeah, you can just run that on your, you don't have to run it inside the VM. And it's pretty cool. You can, with Dalton also, if you edit it in the Docker, you can add custom rule sets to download or add additional snort engines or Suricata engines. So if you want to test on 2.9 and 3.0, then you can add that in there.
Does Remnux have a Dalton 3 installed on it?
Remnux doesn't, but the VM I gave out does. So that was pretty much the
one that you added?
Yep, that was my top secret modification, was adding Dalton and then also changing the X Windows to Xubuntu instead of, I think it comes with like GNOME 3 or whatever for the desktop. And I just preferred that, so. I'll just give it till like 11:43 or 44, so just like another minute, or if everyone's done, then.
You ever just, instead of going to follow the packet, just do the packet bytes itself and put it out there? Put it out?
Yeah, so it will still, you can,
And Wireshark. Instead of Wireshark, you go to the second window, I believe it is, with all of your packet details, like bytes or details.
let me switch back over to the. So this is what you were talking about, is
Go to Wireshark itself.
oh, there we go.
So if you have down there, you see that blue header, just right click on it.
Yep.
Right click on the head, the top blue line. Yeah, go to show packet bytes.
Show packet bytes.
And that's just a better way than following. So say you're looking at the individual packet, that'll give you a JILO to the packet without having to go to follow the bytes, and that'll be just that one packet instead of how Blue creates the string.
Oh, cool.
You can control A in here. This is my secret. I do this all the time. Control A, go to copy that, go to the internet, go to CyberShell.
Okay.
Oh, I'm sorry. You gotta convert that to hex dump real quick.
Oh, yeah.
Just that, yeah. Grab that.
Do like from hex dump.
Yeah, from hex dump that. And then strip the headers.
Nice.
And then strip the headers.
Yeah, your recipe strip header.
Oh, I see. Got it.
And then you can hash that. And then grab the hash from that, and then you'll pop alert on yourself.
Right. And then it's pretty cool. You can then just save that.
You can save that, but it'd probably be way easier to just grab it if you're gonna save it. But I would generate hashes and then push the hash to virus total. This is just a good way to analyze a file without, pulling it down on your computer. And
Oh, that's cool.
own internal alerts
Yeah, and then
All
you
hashes.
report it and good times.
and.
Oh, cool. So just like that.
Yep. You can do MD5, but I like SHA.
Yeah. I know. I just saw they officially retired SHA-1, which seems like, I'm surprised that didn't happen already, but
Get rid of MD5 first, right?
yeah. Well, and that's the thing too, is there are still like a ton of like vendors and stuff when you show alerts in their like product web UI. only gives you the option for MD5, and it's probably because they haven't updated their like databases on the back end of their product yet. But
But then I usually just throw that in virus total and find it. That way you don't upload your, if you're
Oh, whoops.
working with sensitive documents.
oh wait, there we go.
Yeah, see them.
Yeah.
Option virus total. See if we did it right.
Whoops.
Sometimes we get a little creative with the headers. So this is a deep chunk yet.
So we'll search for this hash. Yeah. So and we'll.
Well, it should give you all the.
Yeah, and this payload, I mean, we'll open it up, but this actually is going to be unique per host.
True.
And so,
Oh, the payload itself is unique per host.
yeah.
Is it a tool?
Well, and just to kind of give you a head start, or an idea of what we're going to look at, you can see it's like PK, it's the magic bytes for an archive, a zip archive, and then you've got information.txt and maybe some other stuff in here that looks like it might be related to a stealer. So, but what I'll do right now is just show the correct answer for this signature. So we'll do http.method content post. And so this should give us only one alert as opposed to our 51. Oh yeah, I should point that out is the signatures have home net to external net, and then we just gave it this fun name, flow to server, so it's going to be the host connecting to the C2 server. Okay, so oh yeah, so this is where after you go to your results, you can click on HTTP buffers and see the content that's in there. And this actually, if you scroll down to URI dump, is going to be helpful for our next signature modification or revision. Okay, so now we're doing HTTP URI, and our job here is to add 2 content matches. So, the question that was asked earlier, sticky buffers can have multiple content matches. Choose 2 parts of the URI to add to your signature, and then basically run it in Dalton again. And one of the cool things or helpful things to know is that Suricata will normalize the HTTP URI buffer and actually all of the buffers that it uses, except for there's like HTTP URI raw, which doesn't do normalization. But so for example, you might see this URL come through in a PCAP and see it has these periods encoded with %2e, %2e, which is kind of confusing to look at, but we know that equates to, .. and then this URL is probably looking for or trying to do some sort of like directory traversal to spawn a shell. And so I'll give everyone just a minute to try out the HTTP URI buffer. And if there are any questions or anyone wants a hand with that, I can walk over, or if you want to drop the question in Discord. yeah, and let me know if you get any errors trying this out, and because can be kind of tricky if you haven't modified rules before, but you should be able just to essentially like copy that from the top of the slide and then choose your content matches. And I guess I can also I don't know why Zoom isn't working on this rule file, but yeah, I don't know if it's like my Mac keyboard isn't like translating to. Oh, nice. I was adding in the shift button there because yeah. Okay, so did everyone get their signature that so far? So I really like this tip you showed me.
That may be useful.
Yeah.
I don't know how useful it would be, but I use that all the time. It works when you get like if you get a whole thing, a whole file, because then you can avoid copying your own words. Completely.
Right.
So.
Well, and then the other thing too is we'll talk about this with when we add the user agent buffer is, you know, sometimes like in a PCAP you'll see like this like ... but it's not necessarily like a null character. It might just be something like a non-ASCII thing that Wireshark it's not rendering in like the ASCII view. So you can use hex bytes in your signature. Okay, so I'm going to implement the HTTP URI. I've got my PCAP here. Just going to go back to ASCII for fun. And so the URI starts with content. We'll do /stealer, but you have to spell it the right way. This guy? Yeah. My favorite is when I type like payload or something, download, but mix up the O and the A. Okay, so I chose for my 2 matches, I'm gonna do Steeler and then passwords. Make sure, end with a semicolon both times. Back to Dalton here.
Okay, so semicolon is the delimiter, and
Yes.
and then the colon is just specifying.
Oh.
Yes.
I'm gonna update my revision here too. And this should still just have 1 alert because we only saw this URL in there once. Nice, and my copy paste worked. I didn't have any human errors. So this is what I was talking about too, HTTP buffers. So the whole request line in there, the raw URI, which, you know, you can see is like, if you wanted to use like a raw match, it would still have like all this encoding. Shows you the request headers, the body. So user agent. And yeah, like I mentioned, like, you know, sometimes you want to match on hex if there's like something weird in here, then you can just copy this, and I'll show you how to use hex bytes in just a sec. Okay, so this has been like super fun learning how to presenter mode on PowerPoint, and it's been a new experience for me. Okay. So revision 4, we're going to use user agent, and there's just one user agent in this request, which should be the case for most packets, unless they're doing like something really weird and custom and like add multiple user agents or something in there, but that should really never be the case. So this is just going to be http.useragent semicolon and then the 1 content match. And looking at the PCAP, this is the details window again, or those like the hex bytes of it. This is what we're going to be SIGing on. And one thing to note is when you look here, there is a new line return carriage. Suricata, if you're just using like the user agent buffer, it's not going to include that return new line. So really you just are concerned about that onion client space / 1.0. And so, yeah, like we talked about hex, sometimes you'll see like weird stuff, like maybe a user agent, they included like a hash in it, or like a $, like something that's interpreted as like a special character, either by Suricata, or sometimes people will have like, depending on how they deploy their rules, they'll have some automation that scans through the file, and if it sees a hash or something like that, it's going to break their automation that like parses through all the rules. And so what you want to do is include special, or use hex for special characters. And basically what it looks like in a signature is you just do your normal content match with quotes, but you're going to include the hex bytes in between 2 pipes. So we've got dead beef here just because that's kind of fun. I'll show you how to do that with the user agent. I mean, usually this isn't like too much of a big deal, but like, say someone gives you a screenshot of a PCAP and this is what you have. Maybe if you're OCRing this, like the picture of, you know, the HTTP request, it might interpret this as like a tab or like some Unicode thing and not a space. And so the best way to handle special characters is there's a recipe in CyberChef, which is awesome. So I'm just going to go back to my VM. And so what we're going to do here is got to my PCAP, right click on user agent, copy value. I think this works. Make sure. Yeah, cool. So then you go to CyberChef, and what you're just going to do is 2 hex content, and this is like specifically made for Snort and Suricata rule generation. And so typically what we do with our rules is we do only special characters, including spaces, and then it gives you this hex line right here, but I like to print spaces between bytes, and it just makes it a little bit easier. So hex 20, that's a space. Hex 2F, that's this /, then 1, and hex 2E is a period. So once you've got that, you can just copy this, go to our rule. If you want, you can paste that there. And, oh yeah, get our copy pasta, increase the revision, and another thing I forgot to mention was usually when you're creating signatures, you really want to keep everything as logical as possible. So in this case, you can see we're kind of building left to right. We start with the HTTP method, then the URI, and then the user agent, is down below that in the PCAP. And that will just help you logically read through these signatures. Oops, I'll go back and copy. Okay, so we've got that, and just to confirm, I did HTTP user agent, and then just dropped in that hex content in there. So we'll go back to Dalton, and this should still trigger. Okay, so this is cool because I messed something up, copy and pasting. Possibly, missing a semicolon. Cool tip. Let's go back here. Oh, yep, you can see I just did a regular colon instead. Semicolon. Now this should work. Sweet, there we go. And so this is actually something I learned in another training I took. I don't know how true it is, but you see here in the alerts, I think Dalton just carried that over from Snort, but supposedly that is supposed to look like a pig nose for Snort. So okay, so now we'll go on to our final. Oh, cool. Yep, this is the hex content tip we just talked about.
What is the significance of that, being able to convert to hex?
Basically, there are some characters that don't show up or convert to ASCII very well, and so if you need a match on something precisely, and even if you want to.
A good example for you in
Oh.
Discord of stuff you can look for that would be very annoying to not look at text. You can break stuff very easily.
Yeah, it comes down to, and I'm opening that link, being precise and matching on what you. Oh, cool. I'll have to take a look at this. So, well, and for example, these magic bytes, we can see it shows up as PK and ASCII, which, if you don't know, each file, every file that's a regular file type on a computer is going to have magic bytes. So your operating system knows how to handle it. So a PDF, a PNG, or JPEG, whatever, zip file, they're going to have like a set of bytes in the front of the file. So when you double click on this, your computer knows, hey, I need to unzip this. And Windows kind of also like relies on file extensions, but you'll still be able just to like use command line to unzip this.
Since you were afraid of the link, I posted the strings in a chat.
Oh, let's see.
Made rules on. Made
Oh, cool.
because it is a mess. Broken stuff.
Okay. Yeah, I'll mirror my screen real quick and show that. I'll show it once I bounce over to the VM. So the goal here now, this is our final revision. The usage is going to be HTTP request body, and then add your content there. And you'll see as you scroll through it, like, hey, information.txt, like that's kind of weird. And there's some other content in this zip file that might look suspicious and say, hey, does this file live up to its name? It was called stealer.exe. And so I'll jump over to the, whoops, not the next slide. Okay. Okay. Oh, so basically, you can see that what the GET request here. Let me try and make this. Is that any better? The GET request here is path and then a query and then like some SQL injection. So it's trying to get the database on the back of the web server to process like a SQL command, which usually is like trying to exfiltrate users or passwords, whatever. It can also like cause some damage and just like delete the database. But the web application firewall just responded with a 200. So, and this is,
Good example of when you use hex.
oh yeah, yeah. So basically you're gonna want to, especially one thing that can like really, it's a good example of using hex are quotes. So like when you're typing a document in like Microsoft Word, it's gonna do like these like fancy like curly quotes that look nice, but really when you're programming or something, it's gonna use just like the standard quotes that are above, like if you do shift, comma. So this, even just this is like an example of when to use hex. Okay, so this is still my stream that I was following from earlier. Okay, so we've got information.txt, maybe the like some sort of like database, like password database for Firefox, bookmarks, screenshot. So like, I don't know, maybe this is taking a screenshot of something and exfiltrating that. And just to show the kind of hex thing we're talking about is, you can see PK, and these first bytes are 50, 4B, 04. And what you can do is, if you go to Magic Bytes Wikipedia has a page on it. So you just go here. Oops. Okay, zip file format. It's got this. It will have like an 04 for a standard archive, 06 for an empty, and then a spanned archive. We'll have the 08. I don't know what that is. But I'll pull up the stream here. So probably kind of small. I don't know if you guys can see that, but 50, 4B, 03, 04. So this is a standard non-empty archive. And before I go in and do the final revision of the signature, this is the part where we're going to export files from the HTTP stream. So file, export objects, HTTP, and this is the file. You can see that's like related to that URI. Save that, save it to my desktop, and just name it like xfil.zip. Yeah. Yeah.
That's my,
You know from experience?
yes.
Yeah, right. It quarantines your.
And then they bug you, like, what are you doing? I'm just trying to work. Let me read, see if you might be.
God, at this company I used to work at, it was like a sandbox vendor, and a customer was reporting like, hey, we're getting like false negatives like intermittently, like what's the deal? And so I got like all these like old APT executables and just like started running them through the sandbox over and over, and basically it was just like stress testing the box and causing a false negative. But ultimately I got quarantined by IT or InfoSec for having this just in a VM, and it was like Friday at like 5 p.m. Couldn't get a hold of anyone to like unlock my computer, and I was just like, God, they probably are like just getting like coming up with different ways to punish me at this point. And so
I had developed my little trick there, like just grab the exit phone and drop it.
yeah.
So you don't pop off away from your
So this is our xfil.zip that I just saved, and just whatever like archive utility Remnux has doesn't like it, so you have to use the command line to get it. I'm just gonna make a directory here. Temp, move xfil to temp. Okay. CD temp. There we go. Okay, so this is what was being sent out to the C2 server. And this was information gathered from the triage sandbox. But in the real world environment, or a hypothetical environment, this would be your Windows 7 computer. So if you remember, triage identified it as Eternity Stealer. Well, the file information.txt that was sent to the C2 says Eternity Stealer, and we've got username, computer name, here we go, Windows 7, all the hardware, geolocation, country. Maybe this is where the IP check came into play. It was trying to figure out where the IP address was from, but this probably didn't populate because we were running it with the VM with like an automated like 200 response. So that's kind of cool. We can check out what else is going on here. Screenshot. Yep, it's a screenshot of the desktop. And then bookmarks. It's just the VM had the default like Firefox bookmarks. So yeah, that's pretty cool when you can find stuff like that.
Wait, so what was this? The exfiltration or something?
This was the exfiltration, yeah. So basically, the malware simple runs. It takes a screenshot of your desktop, harvests your bookmarks, your saved passwords from Firefox, bundles them up in a zip, and then sends them to the C2 server. And so to catch that, I'll go ahead and implement the HTTP request body. So I'll copy pasta, change this to Rev5, and then content, and go back to okay, wait. You got to tell me again how to do this. So you right click on,
The answer, if you just want that one back, yeah. Right click there, show packet types. Then I'll just show you that individual packets. Just
Cool.
that one thing.
right?
Not the whole stream. I mean, you can have the whole stream if you want, but you just want to focus down.
Yeah, cool. So then for me, I'm just going to add this information.txt. And because this seems like a,
And that should, if you grab the zip file, it should be able to extract the zip file then
On CyberChef.
on CyberChef. within that packet.
oh, let's see.
You'll have to use the whole stream, because it just won't.
No,
have
that
it,
should, that one should have all of it. The one that contains
Oh,
if you find the packet inside of the exported object, that's usually the whole object. And then you can get,
oh, we go to hex dump. Okay.
So I'm kind of curious, like what you're doing now with like the malware analysis and network protection.
Mhm.
Just doing, how does that compare to like somebody using like firing up a Windows sandbox and using like Process Hacker?
Yeah, so with Process Hacker, I mean, you'll see like once the sample's running, or if you use it in like a debugger, you should be able to essentially like step through it and see where that C2 call is being made. Basically, this is just quick and dirty, a lot easier. If you can get the binary to like reproduce the traffic, then you can just write a signature on that, deploy it like ASAP, and then if you want to spend more time like reversing it and figure out like, hey, like what other changes does this make to computers, or does this make to like our host desktops? You can get some new like IOCs to hunt off of. Then that's kind of one of the benefits you'll get from doing that like manual analysis. But a lot of times what you want to do is get a signature out and like, hey, I know this is at least one box has been infected in this. I don't have visibility into like the rest of my environment. Create this signature ASAP if you can reproduce the traffic that it makes. Then you deploy your signature in your firewall, your sensor, whatever. Then all of a sudden you start seeing all these other computers making that same request, getting alerts blocked. And you can say, hey, like everyone in this subnet or the accounting department, they all got infected by this, and that will let you kind of triage it a lot quicker than if you like spend a lot of time like manually analyzing the binary, dynamically running it. So this just gets you probably protection.
network versus host, that's what it is. This is network traffic, that one would be host.
Yeah.
So you can use the information you gather from the host space to actually go through and run these network detections and basically see where else it's on your network. Or any
Yeah.
future infections under the network. Thank you.
Yeah, yeah, thanks. That was a really good point. So this is my thing, or my signature. I put in information.txt, and hopefully this still alerts. Cool. And so you can see kind of the progression that we went through here was we started out with, basic things like, hey, the direction of this traffic is going from our home net to an external net. This is being sent over a post. Then the URL has some really unique features, like the stealer portion of it. And after that, like, hey, we know this is being sent over Onion client, so maybe it's going to like a Tor address. And finally, information.txt. This is probably going to be in every exfil attempt for this binary because that text file included all the system details. So that's probably a file that is going to be generated every time this malware runs. So let's see. Okay, we have like 9 more minutes. So I'll just show real quick there. There's another sample that is in here and then a PCAP for it that does, it's pretty cool to look at. It's like another command and control type PCAP, and I've set up just basically the same implementation or like the same progression for like sample 2 and sample 3 in this rules file. The solutions file has examples for all of the samples and PCAPs that I have in there. I'm just going to finish off the slides real quick. So, like I mentioned, you can just download the ET Open rule set, and we update it every day. You can see our change logs, and usually, like, there is a good portion of the signatures are in open. Like, not everything is just limited to pro. And usually, there are going to be like references in all those rules. So if you want to like check the MD5 or the blog that it came from, a lot of our signatures come from other like researchers on Twitter or now Mastodon as people are migrating to that. There is a tool called Pulled Pork, which works with Suricata, Snort, and basically any rule set that you want to use. It automatically will download signatures and do you can do like some verification. So we'll like check the hash of your rule file, send that out to all your sensors and just like add some automation there. It also supports using your own signatures. So if you have a custom rule file that you want to send out with your merging threats open rules, it can do that. So, and like I was saying, you find a sample like this, you wanted to pull your signature out ASAP instead of logging into every appliance. You can use Pulled Pork to have like some automation internally. We are really trying to build our community interaction. And so we have a discourse set up, which is fairly recent. We're moving away from the mailing thread or mailing list communication, which is, I think, kind of intimidating for some. But we're adding more and more content on here. People post signature suggestions, ask for tips on like how to write signatures, and we really enjoy getting this feedback, especially like false positives, false negatives. If people find new samples, this is great. And usually if you send something our way, you'll get a shout out on our Twitter or our daily update summary that you can see it's here, but it also goes out to Twitter and email. So if you're looking for more, malware-traffic-analysis.net, this guy has tons and tons of exercises where he gives you PCAPs of like essentially live environments, but he adjusts the IP addresses to like, kind of conceal the details of it. But you'll be able to, he gives you basically a checklist like, hey, like where did this file come from? What happened afterwards? And these exercises are just great for building your skills in like malware analysis, but also signature generation. And so this is the final slide. I don't know what you guys are staying for. You probably should have left after listening to me for 5 minutes, but so yeah, thanks for, I think we're just about, at the end.